The denominator is negative. That should never happen. What should have been the answer? Well, the plus 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 is just one minus. I guess this is correct. Just printing it wrong. No, it's not correct. I mean, the minus 1 is correct, but it should be minus 1 divided by 1. Let's add a static assert. Ooh. Hey Ninja, you're there. You were even in the chat before I was. I forgot to connect. Make. Compile, everything works again. I mean, the denominator should always be positive, so now we find what the problem is. That's a weird minus 1. Oh, an instance is created in... That's already missed then. Wrong, I mean. So E1 is not canonical. Right, this should never happen. Well, actually, no, this is already wrong then. So how do we get that one? Probably because of this. Ninja the Flash, Abhimanyu. So I'm trying to detect what this minus... Oh, here's a minus 1 there. That's correct. And then it changed into the... How? When? Where? No. So I'm trying to detect when, or where rather, the minus 1 occurs here. Static assert doesn't help, I guess. How about I just disallow the requires? That should give us closer place. No. Previous template declaration. We have a for declaration. Constraint not satisfied with denominator is -1. In instantiation of template class, invert. Oh, okay, we found it. I'm having an invert that just swaps the enumerator and denominator, but that is not allowed when the enumerator is negative. Interesting. Yeah. So that's invert of a constant is wrong. The enumerator is always positive. Enumerator can also not be 0, by the way. But well, let's assume that is not the case. No, actually I can add a requires for that maybe. And I will never ever learn what the precedence is here. I'm just going to ask the bot. We have a bot that can do this. Precedence. Oh, it would be nice if I knew how to write it. Not precedence. Yep. No parentheses needed. Error. Oops. Yes, now it works again. That was the only problem. Then let's remove this requires again. Because what am I doing? For declaration, it's still here. I barely did a search and replace for canonicalized, but it is just English, so it should stay like that. Talking about, this is duplicated code. I now have something that does this for me, called constant. I just erased it. I don't have it anymore. No, can't remember it. Wait, what did I do? Okay, whatever. Canonical constant, that's what it is. Canonical constant T gives me a canonical type. So this should also work. Exit code duplication. Thank you, go far, Jan. Hello, Radkul. Excuse-moi for the horrible pronunciation of everyone's name. I'm wondering if instance is conceivable actually. There's no template named canonical constant T. Yeah, that wasn't included yet. Or was it? Oh, it should have been. Symbolic canonical constant T, defined in canonical constant, not the other one. Yep, thank you. Click. Okay. Now, look at the div again to get inspiration. I moved a lot of stuff from constant.h to their own headers. So here you see that it being deleted. All that stuff has been moved to other headers. These headers. Same with the inverse. Yeah, I renamed these things. Zero and constant was swapped just. Put a constant first. Inverse was moved to a header and also renamed to invert. I had to remove this requires. Otherwise, yeah, long story. Yeah, we still have old stuff now. I couldn't and didn't want to change too much. Therefore, I only changed a part of it and then left in old code. Now implemented in the new code, but yeah, in the end I should call the new code directly. Yeah, that's all. To the new files, can't type. These are the new files, a lot of them. Let's look at them. So before I had all kinds of functions, const expression functions, but yeah, all my types are empty, so I might as well exclusively work with the type itself. And I'm making that switch. So now it's just a struct and then it defines a type. Doing the same thing as the functions, const expression functions before, but now we just have types or ints in this case, but template parameters as input and then a type as output by just defining it inside the struct, which you can access directly by adding underscore t, and then it's just this abbreviation of this whole thing with the type already be after it. And because this is structure, you can use specialization if needed, which is not needed or used or done here. But I'm going to do or already do that in other files. Let's see. Let's look at constants. I'm defining no less than 5 things here. Something that will test or return some type where value is true if it is a constant, and or if it is a constant and 0, and if it is a constant that is 1, if it is a constant that is -1, and here, and finally the fifth, if it is a constant that is less than 0. So by default all have been defined as standard false type, which has a value of false. And then we define these underscore v thingies, abbreviations, so we don't have to type the double colon value every time. And then we actually implement it by specializing those for those types that need a value that is true, aka true type. So a constant, well, that would be a constant with any numerator, denominator. 0 means that it is exactly that type. And this is the type of 1, this is the type of -1. And then here we have finally a specialization for negative constants. So yeah, I think it's cleaner. Let's next do negate. So kind of the same thing. Start with some struct. Make the abbreviation, the underscore t thing. And then do the specialization for when this thing, what this thing should do, or rather. In this case, it is only specializing a constant. So I can only negate a constant using this thing. If I try to negate any other type, well, then this specialization is not used, so it will use this one. and then that thing isn't even defined, let alone that it does have a type. In other words, then we get a compile error. So negate only works for constants. But if maybe at some point I need a negate to work for other types, then I can just add it here. And then the negation is quite obviously, well, just negate the enumerator. I want to be more consistent. I think I have 2 arguments. I might call them 1 and 2, but I already started to use just E. If there is only 1 argument anyway. If there is not a 2, then why should there be a 1? Not to mention that I should start counting at 0. Yeah. And the next one is, did I make the same problem here? I don't think so. No. This is just the numerator, denominator. Come on, constant. We already looked at it. Also, no ones there. The next one is, let's say, invert. Also just E here. Okay, for declaration of invert, the abbreviation, and then the specialization for a constant, demanding that the enumerator is unequal 0, otherwise it would be nonsense. And we cannot divide by 0, namely. And then, yeah, inverting a rational is just swapping the enumerator and denominator, but we need to keep the denominator here positive. So if the enumerator is negative, then I'll multiply that with -1, and then it's positive again. Just fix that one. Inversion of a symbol becomes the power of that symbol to the power of -1. And the invert of a power with a given exponent is obviously that exponent negated. However, if that exponent equals -1, then just return base. Otherwise we get a power of a base to the power 1, which is not allowed. Because, yeah, then you get a non-canonical type. Base is just the type that we want to have, not base to the power 1. That's, and then I have the invert of a product, for which I just take the product of the inverse. I have to take into account that the product demands that it is sorted using is product less. So depending on which one is less, according to this thing, I put this one first or I put the other one first. Basically, it's just a product of the inversion of each expression. And here we have an E1 and E2, of course, because there's 2 of them. The inversion of a sum, yeah, then the whole sum to the power -1. That can't be right. This shouldn't even compile. A power is only allowed to be used on a symbol and a constant, not on a sum. I have exponentiation for that. I think this should be should have been exponentiation. But yeah, that's also dubious because the exponentiation of the sum. Wait a minute. Okay. The big difference between exponentiation and power is that for the power, well, power can only, like I said, be a symbol and a constant, but more importantly, that one is heavily automatically simplifying itself, while exponentiation is more like, yeah, okay, the user told me to exponentiate this, so I will, and then you just get the type, period. Even if the end result is really something that could be simplified. It just gets too complex to do that, so no more simplification, just an exponentiation and that's it. Nevertheless, we can, of course, invert an exponentiation. So an exponentiation has a base and an exponent, and then, well, the inversion of that is that you negate the exponent. And in that case, I do some kind of, optimization. I refuse to do exponentiation to the power 1. So if the exponent is -1, then we just return the base. Now here's the old invert. Old invert is now implemented in the new invert by getting the type of the this one returns a type, and then instantiate that type. So the old one was a function that returns an object instead of a type. But I want to get rid of all the old functions. But okay, for now it's still in here. So I did invert. Now let's look at the multiply. For declaration, the abbreviation thing, and then the only thing that we can multiply at the moment is a constant. So you can multiply two constants like this, but you have to pass template parameters. So you have to pass the numerator and denominator of both constants. Now you'd say, well, but then why not pass as template parameters the constants themselves? Wouldn't that be more logical? And the answer to that is yes, certainly. But then that would not be a specialization. I think I can make it work though, but this one definitely has to exist as well. This is the actual specialization. Implementation then is that the type becomes, we just multiply the numerators and the denominators, which might cause then to have a common factor, so we have to run it through canonical constant to make it canonical. But okay, let's say I want to implement doing a multiply t, passing a constant and a constant. Not sure if we even want that, but maybe. I was thinking of using requires, but I think you have to specify the same requires while specializing a class or a struct. So my idea was I just define, let's say, this, but then we do requires is constant. And then we can implement this one in the other one, as the other one, by then passing the enumerator. It's an int, right? So as enumerator. And then the same but for E2. Let's see, I'm an idiot. This already works. This is just a local template to find these things. But this is specialization, so it is a constant. It's already just never mind. Just forget what I just said. So if this expression is a constant and that expression is also a constant, then it will use this one because constant. The last one, new files, add for declaration abbreviation and adding, also only constants. Right, so next, it's a bit like an open heart surgery, this. Except that I forget what I already did, what I still have to do. What is next? I have to search for all the declaration types, and we have to get rid of all the arg1 functions, and of course I have to get rid of all the member variables of everything. That was the main thing. Pretty sure constant has already nothing anymore. Never had it. Symbol that is free of member variables. Just have to go over them. Going to go over all of them, I'm afraid. Yeah, so constant does not have any members. The size of the constant is well 0, but size of is going to return 1, but there's nothing in it. Next is exponentiation, and that one has a base. And I do want to get rid of it, but in the meantime I learned that it's better to do it one by one and definitely not do exponentiation first, but first everything else. So I'm going to skip this one then. Power. So the using is just yeah, it's not a member variable. The static's also not. Or at least they are static. So this one is already done. Okay. And then we have products. Okay, I was working on product, I suppose, because it does not have member variables anymore. But it does still have the functions that used to be the accessors for those member variables. So maybe I should continue with product. We do next. It is some still has member variables here. 2 of them, but yeah, I should do product before some. Finish it. And symbol doesn't have anything anymore. Got rid of that. So, okay, product it is. To continue with products. And I want to remove these 2. Scary, but okay. Let's just begin with removing them. And then, of course, they are private functions, right? Public. Oh, never mind. But I expect them all to be in this, mostly to be in this header anyway. So now I don't have arg1 anymore, but I do have the type. So I have to replace this line and many other lines with something that just uses the type. However, this is operator star, which must return object. Means C++ just, I mean, I don't know, if I want to use the multiplication, the star as multiplication in C++, then it's just going to be operator star. And I have to pass actual objects, and I get an object back. But I don't really want to use these objects. I just want to use the type. So the type are going to be E1 and E2, obviously. So I also want to get rid of using arg1 and arg2 completely. And I think that in the end that just means that we have to get rid of the calls to alt. Alt whatever. There's just 2 functions, alt multiply unequals and alt make power. But alt make power, let's begin with this line here. Alt make power is now implemented in terms of make power E1, E2. So we can put that literally here, where then of course E1 and E2 must be the types of arg1 and arg2, which happens to be also E1 and E2. And then instance, but this instance is only required because I'm returning from operator star. So this should work. It doesn't because I removed arg1. No, that was a bit too fast then. It's unlikely that it doesn't work if it compiles, but okay. Now, likewise, I might be able to do all the other make powers. So this then becomes make power T, and then we pass this as template parameters, where of course I just need the type of these things instead of the arguments. So this was type E1, and this is then type name E2 for arg2, and arg1 has the type arg1 type. But then I have a type. I no longer an object. Now I can do instance here. But then I still need to call arc2, and I want to get rid of that. I also want to get rid of this. So we hardly made any progress. Hardly. Nevertheless, let's check it anyway like this. I'm making really small steps. So that still works. And then let's do the next make power. Make power T E2, comma, type name E1, arc1 type, instance. And here's another one. Make power T, type name E1, arc1 type, comma, type name E2, arc1 type, instance for now. I think that is still working right. Naked or make it totally works. Now okay, let's do old multiply on equals as well. That one is also implemented already as well in terms of types. So this one becomes underscore T. Type of arc1 is E1. Type of arc2 is E2. And now we have a type, but we need an instance. That one line is correct. And this one can also be made correct. E2, E1 instance. Now this one is the same as arc1, arc2. And here's an arc2, arc1. And then we have a few that still use the operator star. But we can do the same as with the make power, make a start anyway. Type name E2, arc1 type, comma, that instance. Now that won't compile because I need the type of this thing, but we can do the declaration type of whatever expression at the moment, for now. Same thing here, T. Oops. A bit too hasty there. This is still the multiplication. In the end, I'm going to need that, but well, For now, I just do the multiplication with objects, of course, and then take the type of that again. Could did them? Oh no, here's two more. And they look is oops annoying. Do them in parallel. It's not hard enough. So just kidding. That belongs to this. We need an instance in both cases. For the return, then this is type name E1 arc1 type, and this is type name E2 arc2 type. Oops, let's not make mistakes. Arc1 type. And these are the products again, multiplication, so just again a declaration type of that multiplication. Compile. Shit. Oh, type name. Well, I can live with that one. That's just a typo. Oh, we did not make any mistake. Very good. Therefore, we continue with getting rid of the multiplications. Now, this is going to be a little bit harder. Every time we have a multiplication, I also have a declaration type. So let's search for that. Maybe I should just use multiply here, right? So I need a type, and we did define multiply type, although that only works for constants. So what if I want to multiply E1 with the type name of E2 arc2 type? So now I got rid of the star, I got rid of the declaration type, and we just work with types. Got rid of the arc1, got rid of calling stuff. The only thing I need is that the multiply t is returning the correct type that belongs to that multiplication. And that's not going to work because E1 and or this thing is not going to be both a constant. Undefined template, symbol. Well, let's add it. So now go to multiply, and I'm going to add a specialization for symbols. Let's just template something, and then we have a struct multiply, and then we get here a symbol, and the symbol takes an ID. So we have two symbols. Symbol ID1 and ID2. So those are the template parameters that we need here. Need to deduce, so the compiler needs to deduce well. Using type. Well, there's a product, right? Or a power. The thing is that in the end, It kind of depends, you know. If ID1 equals ID2, then it's the same symbol, and we just get a power of a symbol to the power 2. While if there are different symbols, then I get a product. Or it can say declaration type of one symbol times the other one. But I think it's supposed to be recursive call. I mean, I was implementing operator star, and that was implemented in terms of operator star. Yeah, so it's recursive. So I probably should and or want to simply define multiply for any arbitrary type except constant, and then implement it again in terms of that operator. But then we have a problem. Which to define first? If I define this one first, and I use operator star here, then operator star is not defined yet. Or is it? Maybe it doesn't care because it's a template. Yeah, probably works. Just define both templates, and then only at the time it's instantiated I really need them. But then both have been defined anyway already. I don't think I need it right here for the symbol, but let's immediately try to do this to see if it works at all in terms of the, you know, which is defined first. So I want to use star, so I need objects. Now I could do something like this. You know, make temporaries and then multiply it. Yeah, and then I needed the result type. So then again a declaration type around that. And God knows what that gives. So maybe also remove cvref or something. No, the whole type is. Surely this one has an underscore t version. But let me see if I got that one correct. Yep, so this one. Okay. That removes constant, volatile, and reference and everything. We no need if they are there. Okay, the point is that I don't want to create a temporary here, and it's not needed. You can do something sneaky, because the only thing I really need is a declaration type. So you can get that without actually instantiating something. And now my memory is not working anymore, because what is that? How is that done? I have no clue. I'm just gambling that I did it before. I'm sure I did it before, but I'm gambling I did it before where declaration type was being used. Yeah, declaration val, that's the one. That makes a value between quotes. I'm not even sure, but well, anyway. Yeah, here's an example. So you take the declaration type of some formula where you need an object, but instead of actually creating a temporary, you send a declaration value of that type. And apparently you need parentheses, so this is what you need. What is the difference between remove CV ref and DK type? This one says, if T is a reference type, provides the member type def type, which is the type referred to by T, with its topmost CV qualifiers removed. Otherwise, T is the topmost CV qualifier. Otherwise, if it's a reference, one reference is removed, and then the possible const and volatile are removed. If it is not a reference, then it removes the topmost const and volatile anyway. And DK performs a type conversion equivalent to the ones performed when passing function arguments by value. Formula is T is an array of U or a reference to it. The member type is U pointer. Otherwise, if T is a function of type F or reference on the member type is standard add pointer F type. Yeah, I don't think I need a decay here. I'll just use the other one. And we still need to have a look at this one. Converts a type T to a reference type. Making it possible to use member functions in the operand of the declaration type specifier without the need to go through constructors. The standard declaration is commonly used in templates where acceptable template parameters may have no constructors in common, but have the same member function whose return type is needed. Yeah, for example, when you have we don't even know what T is. You know, T could not have a default constructor, period. I think that's the main reason for not wanting to use the temporary. In fact, I don't think... actually, symbol does. Symbol has a default operator, so this would work. But say symbol does not have a default operator. Or worse, you don't even know that it is a symbol. So this does not construct a symbol. You just get a reference to the symbol. And therefore the operator star can be found. And since that is const expression, I hope, better would be, it can then calculate what the return type is, because it has an auto return type. Actually, not even convinced that this is going to work, but I think it do, hopefully. It doesn't know what the symbol is at the moment when I include this, which is correct. Now I'm not sure if I can include symbol here. Maybe I just need a forward declaration of symbol. Yeah, it seems to have worked. I mean, the error is now about a symbol multiplying with the product. So apparently we did pass the multiply symbol times symbol thing. But it must say that if I want to continue with this and finish this, then I need all the types that multiply work on. So the question is kind of like, can I include all the headers at the moment multiply.h is being included? It's included in constant.h, hello, but I think at the bottom, more or less at the bottom. So as long as the others don't need negate and etc., but I'm afraid they do. We have a header inclusion order nightmare here. Would be really nice if we could work with forward declarations instead of actually including the thing. Yeah, but is that going to work? Because I think that this definition of the template does probably not really need the definition of symbol, even though we're calling star. It doesn't even have the declaration of the star yet, I think. At this point, the moment I include it. So it's okay, as long as we have that definition by the time we need an instantiation of this. And yeah, that should work, because I'm not sure. Let's just try to do forward declaration. So I'm going to try forward declaration at the top or lower. Let's just put it at the top. Forward declare symbol. Yeah, same error. So that might just work. So then the next thing is that any arbitrary product must work. Which means, of course, that we want to forward declare products, because I definitely don't want to include it. And then I want to make this work for actually anything, as long as it's not a constant. Which means that this is the specialization, and this is the anything. So let's not do this, we just do this. So now it's the default way, and then it's specialized for two constants. But if they're not constants, so we're going to use these expressions, which then means that this is just... And now you see how important it is to use declaration value, because I really have no clue anymore on how to construct these things. Don't even know what the type is. Too many of these? Yeah. So that's the multiplication between two objects between quotes of these types, where the operator star that is being used here isn't even defined yet. But that's apparently okay until we actually want to instantiate or multiply with the given E1 and E2. And that's reasonable, because as long as E1 and E2 are not known, which of course is only until the multiply is instantiated with those types, we wouldn't even have any clue which operator star to call, because the types are not known. And then, yeah, that gives us a type. I don't know if this is necessary, but why not? Pray, and it compiles. Ta-da! And the test it runs. Wow, okay. Product.h. Sorry for the dizzy scrolling. Yep, here's the multiplier used for the first time. It should now work for everything, right? So all the stars now can be replaced with multiply. So we do multiply t, and then this returns a type. So we can now remove the instance from that. And then the type of this one. And then we're going to need an instance again at the end, of course. And this is then E2 arc2. Line 223. Yes, I'm going to do it line by line. That all worked. I'm not regretting that I took the detour of first writing it with objects and functions, because I really don't see myself having done this directly. Like from scratch, type in all this stuff. But I guess it's just getting used to it. Well, I'm already getting used to it, I must say. Definitely harder to debug, let's put it that way. If it's wrong, it's all compile time stuff. No, let's test this first. Oh shit. That wasn't too bad. Those are 2 multiplications. Let's first do 1. Okay, so I think now I got rid of every call to arg1 or arg2 in this function anyway. Now we have an operator caret that has still calls to those things though. But that's it. Yeah, can still not remove them then. Still have to implement this as well. Now think about it. Actually, this is multiply t. And we can implement this thing as just multiply t of E1 and E2. And then instance of that. This thing is now only ready to be translated to multiply t non-recursively over, well, bleh. You get what I mean. Yeah, maybe I want to do that someday. Let's leave it now. For now, I do want to implement this one then as a multiplication. So this becomes multiply t of type of argument 1, comma, the invert of argument 2 instance. So invert.h includes product. Why? And then product includes invert again. So maybe this one has to go the same route as the multiplying, and in that it does not include product, but it just forward declares it. See, it includes every shit. What the hell, man? I think I can do this with just forward declarations. Definitely product. Let's try product. Try product first and then the rest. This is the right file. Forward declaration of product. Yeah, but I don't know what this product is. Oh, but it's in sum.h. So, okay, that's not really what? And oh, what? You know, there's some. If I call this, why is sum not including product.h then? At the very least, it should do that because it's using this product. If symbolic printing anyway. Nah. It's hardly worth including, I have to admit. Yeah. Yeah, and then we get the same error again, because now invert includes sum still, which includes product, as it should. So we can also not include sum then. So let's try to forward declare sum. And pray. Unknown type, sum type. That is in exponentiation.h. So now we get the next one. Nothing works, right? You cannot include. Yeah, wait a minute. From invert.h cannot include exponentiation. So let's do exponentiation for declaration as well, which uses constant type. Well, we do have constant. Oh yes. Nope. Now we don't have is product less in invert. Yeah. That is indeed only defined in after knowing what product is. Seems to be a little bit of dead end. Nevertheless, I'm gonna finish it. Let's not include anything at the top. Let's just have a certain order in these things. Some should go there. Symbol and power should go above here. For declaration of symbol. For declaration of power. Now, if a complete moron is looking at this, they might want to know that these are for declarations. I'll add it. And then the problem seems to be that this one is known actually. Negate is known, isn't it? I'm not even sure. I think negate would only be known if I include it. Negate is not using invert, right? So I can just safely include negate here at the top. Yeah, this seems the only thing that is really necessary to declare, or maybe actually I can also for declare that one. Yeah, why not? Everything else is for declare. That's the last one, so let's not do difficult and just for declare this one as well. Oh, is that even possible? I think it is possible. Nah, I have to declare it. Then I have to forward declare this one, or maybe. I wonder what happens if you do this one twice. If it is a problem, I can just use this, of course. Maybe I should do that, just to avoid problems here. No, symbol type is not known. Yeah. So that means that what? I can't for declare power? The point is, I've kind of used concepts to not resolve overloading. No, the word overloading is not right. Resolve. It's not called overloading, I think, when it is a class. But anyway, let's say you have the specializations. Then you want to say, yeah, but this specialization should only be considered when this or that concept is true. Then you use concept correctly. But what I did is more like, if you try to use a power with anything else than a symbol as the first template argument, then it's just wrong. But I'm starting to see that that's not the correct way to use concepts. Instead, well, it must be a symbol, but yeah, I mean, it's not like there is a power, another power that accepts something else. Or I could rename exponentiation. Actually, if I rename exponentiation to power, then it would be okay, I suppose. Then I have a specialization. Nah, also not. No, never mind. Anyway, the idea is to just use expression here. So here it is a correct use, because now I removed the requirement that base, the first argument of power, must be a symbol type. So it can be anything. Then if I would use expression here as well and allow base to be anything, then it would return true for a type where we have a power that starts with anything, which then would never be called until I actually try to instantiate that type, which is a bit late. So if instead it should be that it's not a power. If I have ever a power with an arbitrary type here that's not a symbol, then I don't want that to return true, because it's the wrong type to begin with. Although it's kind of, yeah, it's more an error actually than that it is not a power, right? You could say it is a power, but it's not a power that you are allowed to use. I mean, it's like literally a power. Maybe I could use expression as well, maybe. But well, okay. Anyway, this will compile, so I'll just leave it in. And then I want to change. I still want to catch the error that someone tries to pass a base that is not a symbol by adding a constructor which then has a static assert. So instead of the compiler now saying, sorry, I can't find the type power, it says upon instantiation of that type that it is the wrong type. Which is later than when you try to use it, but yeah. At the very least, this is now working because now I don't have symbol type here. You omit a constructor initialization of power symbol constant. That's weird, of course, because they definitely should exist. In instantiation of function template specialization, blah blah, no known conversion from const symbol to const power symbol constant for first argument. Oh, it's a copy constructor. Bullshit. Move instructor. Oh, I killed the constructor apparently. I added a default constructor. It's the whole thing. It should never have passed a base in the first place. We no longer do bases here. E1 is the base. No, I just want the type and then instance. Same thing here. Power is the type, blah 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 blah. Instance. No major constructor initialization of power, blah 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 blah. Very interesting that it worked all this time, and now suddenly I get all these errors. Okay, point. Power no longer takes an argument. Okay, no magic constructor initialization of M, aka power, and we still have powers with arguments. M is a power and N is also a power. No arguments. Thank you very much. Right, that works. Now what did I do last? I don't know, still working on product, I thought. Yeah, this one. So apparently we can do the exact same thing with negate type. As in, it was already defined for constant, and everything else should be this. Yep, so let's try that. So no longer using the argument. And then we are returning negate type of E instance. But then negate is not defined because it's not defined. So we make it a general negate that works for any type, and then specialize it for a constant, which is done differently. And then here we do the same thing as the other one, as in the other one being multiply. Let me have a look at that, because multiply, right? Yeah, and now negate. Which then must be declaration type E, a multiplication with a constant. Declaration, I could use a multiply here, right? Or I remember I said negate is not using multiply. So maybe I shouldn't. But doesn't really matter. Now I'm going to use multiply. Should the multiply then not already do that? Dude, just multiply. It's more like multiply is not using negate. Let's put it that way. Multiply constant minus 1. I think I have to type that with E. So by default, we multiply the expression with minus 1. And if it's a constant, we just negate the numerator. Where then multiply t is still defined as a declaration type of declaration value of that constant times. So it's in the end it's still implemented in terms of the operator star. So yeah, I think I have to move the operator star code to do this structurally and then do everything in types. But I guess this still works. or not, or temporarily not. What is this? No member named instance in some. Oh, okay, well, it had to be added someday. No magic constructor initialization of some. We don't have a default constructor, or what the hell? Oh, this thing not have a default constructor. Oh, because it still has arguments. Yep. Yeah, that's what you get. Then, What I really would like is that some simply has only a default constructor, because that's what it needs in the end. Gonna need to do the same thing as I did with product. The product does have a default constructor, and I just return instances here by value. Let's do that here as well then. We can delete these and these. Term. I could use a term type then. Using term is negate TE2. I don't like that. I just define negate as multiplying with -1. Or is actually, if you put a minus in front of it, it's using negate, I guess. It should just work. If it works, then it works, you know. There's more here. There's more here. So arc 1 or 2 underscore followed by anything but a T. The T of type. These are the last ones. This can definitely be E2. And this can be E2. And this one is harder. Print on. Oh, you just need the type of that then. Print on should be static. So convert the above thing to a type. Well, that should be some T of negate T of type name E2 arg1 type, comma, type name E2 arg2 type. And the end of the negate. No, the negate is only here. This is the sum. So the end of the sum. Minus E2 arg1 plus, so it would be the sum there. 2 arg2, yeah. So that's what the dream code, what you would like to have. But sum T is not, wait a minute, I call that add. Yeah, what's saying sum is not highlighted, but doubt that is going to compile. I missed that one. Term is now a type. Oh, all the way to the testsuite. No, my sum. The sum is now suffering from the same thing, that it does not have arguments anymore. I can just delete this, right? Because we work with types, and the type of x is already given here. Well, minus y is just simply that part. So we're passing the whole thing already as template arguments, yeah. Oh boy, and then we are suddenly editing operator plus of some. No, so do a minimal amount of work. Oh, and it's really annoying. And so is the rest, basically. Shit, a lot of them. Yeah. Type name e2 arg1 type comma it in some, right? Instance. And this is then E1 and this is E2 and this is then arg2 type with a type name in front of it. And then yeah. Oh, like that. Yeah. Okay. Non-static member function of what? Some, I think. And then, out of nowhere, there's an utter shocking surprise. It compiled. I was going to say it worked, but no. It did not work. Well, almost. This is no longer what we expected, apparently. Minus x times a minus Oh, what? Totally looks like minus 2 times x times a. Maybe that's the reason. I copied it. Let's have a look at what it should have been. VI symbolic testsuite at CXX or not. Symbolic. That's the only one that is. Yeah, it's the minus 2 probably. Let's just admit that it is the minus 2. No, more is wrong. Anyway. Doesn't even closely resemble it. I think it's another test then. Let's see. I don't know. Suspicious that there is no A in it, for example. Well, there is an A here. Minus A times X minus, I don't know, B times, yeah, no. I don't know. Yeah, that has to be the one. Let's comment it out, see what still works. That works. So it almost works. It almost works, except for this difficult thing. I broke it, but in a subtle way. A subtle way. I do see a minus x times a here. Why is there not even a 9/4 here? It's like completely not okay, the answer to results. But it must be related to sums, so let's try to make a simpler one. Let's try to make a simple one, like a plus that times x plus that. It's a multiplication of two sums. I might as well fill it in. That should become, I think x is less than a because I declared it first. So x comes first. X times a And then, of course, 3/2 c times a, or x times plus x times 3/2 c. 3/2 times x plus 3 divided by 2 times a times c plus 9/4 c squared. I think that should be the answer. Yeah, well, maybe I should comment this one out. Okay, it fails. But I'm not convinced it didn't work. There's a 9/4 now. Put this c squared first, yeah. Let's see what I get. What is that? So we have first that, and the rest is okay. So it's just a reordering. Unfortunately, so this one just works. Then what is it? Let's make a negative. This one is a negative as well. So make both negative. So just removed a few terms, but the negative stuff is the same. Which means that this becomes a minus, and this becomes minus, and this becomes a minus. And I'm not sure if that's true actually. A times, yeah. The x is also negative. This one. It's like everything negative. It's like 100% negative now. Yeah, of course it is. Still works. Jesus Christ. Okay, in that case, I'm going to add 2 times b here. No, the first thing is already the same. That should give us 2b times this as extra terms. I don't know the order of that really. I'm gonna guess plus 2 times x times b. And then we have a 2bc times 3/2, so that's 3bc. Okay, so my 9,4c squared was replaced with x times a. What? Now, how to find out? Well, that happens. Yeah, it's just a simple typo, isn't it? I typed somewhere the wrong number, like a 2 instead of a 1, or a 1 instead of a 2. Got the wrong type. But where? Well, I bet it was in Sun.h. Yep, there it is. The last line, obviously. Sun.h. So this should be this arc2. This should have been e2. At e1, comma type name. The rest is okay. How do I find that line? It's not like 268, 272, 270-ish. Probably gonna find it like 70. That work. Yep, it's new Vim. Yeah, that should work again. Probably time to do another git commit, right? Oh, I don't know, depends, you know. You don't really need to know higher math to become a programmer, but if the program itself needs you to know mathematics, then you can't write it. So it definitely is very, very, very handy. And if it would be like that you don't know math because you're always scared of math, or you're just not capable of learning it, then I don't think you can be a programmer either. In my eyes, yeah, someone who is a good coder will also have been able to easily learn math. That always was your view. No. Sometimes I read about those people on Reddit or something like they don't understand math and they were always bad at it. Yeah, I just no. I can't believe those people would be able to be good programmers. It's kind of related, isn't it? Structural thinking, logical thinking. Still can't get rid of these things because they are used here. Operator, something. Yeah, how do we fix this one? Kind of surprised that the negate is working. Yeah, I meant it's difficult. I would say it's related to IQ. Being able to think abstractly. I mean, someone who's good at higher mathematics, I'm not talking about high school mathematics, but at university level mathematics, they definitely are capable of thinking in a certain way that I think is very closely related to what is required for being intelligent. Of course, you can be intelligent without knowing any mathematics. Just don't go to the university. Done. But it proves something. So again, I think that it is possible to be, to learn C++ and to write code and programs without knowing any mathematics, except that you cannot write certain programs that require mathematics then. But if you are not able to learn mathematics, then I think you are also not able to be a good programmer. That's what I said. I would fire them if they worked for me, basically. But yeah, no. ChatGPT is extremely bad. Extremely bad. Waste of your time. Don't go to ChatGPT. Well, you can see it as a replacement of Google, but ChatGPT always says things like it is absolutely sure that it is correct, even if it very often is not. So I think you need to acquire the skill to use Google. If you have an error, Google it. Way better. If you really must, you can ask ChatGPT, but then you better understand exactly what it says. And always catch the cases where it produces nonsense. And trust me, it often produces nonsense. Let me see if I still have that example. I forgot. ChatGPT. No, it is in Dutch. I'll translate it for you. This is language, right? I mean, that's the strong point. I'll give it away already. This is the strong point of ChatGPT, the language. There is a special word for the grounds around a building, a many-story building, usually containing grass. A high flats English, a high flats do have that. It's not allowed to build anything else there. Which word is it that I'm looking for? Then it says the word that you are looking for is binnenplaats or binnenhof. I don't know whatever that is in English. And this refers to open area around a high building, usually with grass, maybe some, what is that called? Planting? Whatever. Where no other buildings may be built. Okay. And I said, that's not a word. Oh, excuses for the confusion. The word that you're looking for is binnenhof. That's like the same word. I just told it it's not a word. It repeats it. What the fuck, dude? How intelligent can it be? Okay, binnentuin. So that's like an inner garden. Why inner? I'm talking about the area around a flat. And now it's more like as if the building is surrounding it. And then there is an inner garden in it. Nah. Anyway, I say, something else. Oh, I understand. The word that you're looking is, and then it's not a word. It is two words. You see the space here? It's two fucking words. I'm not looking for two words. I'm looking for one word. So, ignoring whatever self-secureness else said, I said, no, it is a single word. My excuses for the confusion. The specific word that you look for is, again, two words. I'm like baffled, man. this is ChatGPT 4. This is ChatGPT 3.5 now, but this is ChatGPT 4. Yeah? I was still paying for it then. So it gives me 2 words. I say, no, it's a single word. Oh, my excuses for the confusion. You want a single word. Well, then the single specific word that you're looking for is 2 words. So I say, no. The specific word that you're looking for is probably... Oh, it went back to this one. I mean, I said, no, it's a single word. It tries something else or 2 words, and then it goes back to the first one. What the fuck? I mean, do you really think that ChatGPT can help you with coding? Finding bugs or interpreting errors? Or doesn't even understand this? This is beyond... I have no words for it. So I said no. Excuses for the confusing. That's just always starting with that, right? The specific word that you're looking for is, again, 2 words. I said, no, it is 1 word. Understandable. The word you're looking for is bouwkavel, which is 1 word. And then I say, I thought that it started with a K. You see, so now I'm suggesting that the word that I'm looking for starts with a K. Oh, I see what you mean. The word what you were looking for is bouwkate, which starts with a B. Can't I just say, I don't know what you mean? So I tell it, that starts with B. My excuses for the confusing. The word that the word that you probably are looking for is bouwstrook, which starts again with a B. So I repeat, that begins with a B. You're right. My excuses for the misunderstanding. The word that you're looking for is probably bouwperceel, which still starts with a B. I say, that starts with a B. You're completely right. My excuses for the confusion. The word that you're looking for is probably bouwstrook. That is exactly the same word as that here. You see, here you get, I think this is like looking under the hood of ChatGPT. It will always sound like, well, now it started to use waarschijnlijk, which is probably. So that's as insecure as it ever gets. But it has no idea what it's talking about. It just repeats the same word. I already told it that that's not a word. I already told it that it's starting with the wrong character. Okay, anyway, at that point I remembered the word and I told it. It starts with an M. Oh, I see. The word you look up is membrane. How is membrane has anything to do? That's what I say. Since when is membrane a word that is being used for the empty area around a flat or a building? You're right. That's not the right term for the empty space around a flat. The specific word that you're looking for is maint. I don't think so. Good for the warning. The word that you're looking for is marge or marginaal gebied, which is 2 words again. No. The specific word that you look is mandeligheid. I don't know what that is. None of these words has anything to do with flats. Finally is admitting it. I see I still didn't find the correct word. I'm very sorry for the confusion. Can you please tell me the right word? Wow, now do you seldom see that? This is interesting. So I tell it the word, right? So I say the word I'm looking for is maaiveld. And then it replies, Oh, of course, the word you're looking for is middenstuk. I just told her the word. How is this a reply? Fuck. So I typed it, consider yourself uninstalled. Goodbye. And I uninstalled it from my phone and I never used it again. If you need assistance again, yeah, no, it's a waste of time. Well, those as horrible. Yeah, I don't have the tab open anymore even. But Gemini is as bad. So yeah, I also I still have advanced, but when I get to the end of my trial, this is also ending. I'll live my life without AI for the foreseeable future. And the same level of stupidity I see with programming. It's less obvious then, but it can. If you ask me, if you ask a question that it has seen hundreds of times, literally, like someone else asked the question as well on Stack Overflow, and answers were given, and it's sort of parallel in that, then it can repeat it. But then you can also find it using Google. There is no reasoning, there's no understanding, there is no intelligence, there's no memory, there is absolutely nothing at all that ChatGPT can do to, self-reflect and test if its randomly generated answers are actually making even sense. I don't know. It's just a random word generator that matches things that it saw before, but there's no understanding whatsoever. So yes, if you ask it a question that has been answered hundreds of times on the internet, you will probably get the right answer. But if you require any thinking, any logical thinking at all, it's non-existent. So you just get nonsense. But that nonsense then is formulated in the way that good answers usually take. So it starts with, oh, I understand. And it ends with, and this is the answer that you were looking for. Not because it understood that, because those phrases belong to an actually correct answer. It's hardly better than Eliza, in my opinion. Pathetic. Argument 1 exponents. I think I just should stop and watch a movie or something. Just tiresome. This recursive call back to the same thing, right? Yeah, I just need an exponentiation, which I don't have yet. I'll call it exponentiate. To show the utility. Utility. I think that was needed for which one? So also using this one. Now I've got a declaration. Yeah, value it was, and then template parameter base to the power standard declaration value. Yeah, constant type. What? Exponent. Probably should have an is product header with is product less in it. Although, yeah, it's only needed here. I don't know, man. It's not like I need it anywhere else, so. just exponent. Don't understand all the mirrors. If this is a constant, so what? You just, I don't know. reconstructs the argument here, basically base. No, base argument 1, which is the constant. But that's what I'm doing here as well, so I don't see it. I think I can do this. Let me go. Arc1 doesn't even exist. But that should always work. Zip. Okay. Highly dubious. Yeah, what the fuck? Mhm. Yeah, and then everything again, but now for sum instead of for multiply. Or, well, product, I mean. Hopefully I can do this faster. This is at the instance where we add result of multiply t and another multiply t. Okay, the first multiply is between argument 1 and e2 argument 1 type. And the second one is between e1 and e2 arg2 type. No fucking way. I checked it and rechecked it. Oh, it was arg2. Yeah, whoops. I typed e2 when it was arg2. So really, this is just e2. And this is e3. Yeah. It also makes a lot of sense. arg1 is e1. This is a multiply. with arc2, which is E3. And now we add another multiply between arc1, arc2, which is E2, and arc2, which is E3. What is this? A sum? That's like 4 terms. Is sum of a sum and a multiply. And this sum is then again a sum and again a multiply. This sum is between 2 multiplies. Arc1 is of course E1. Arc2, arc1 is E3. Arc1 again is again E1. Arc2 is E4. Arc1, arc2. Arc2, arc1. Arc2, arc1, arc2. Multiplied with arc2, arc2. So it is 1, 1, 3, 4 and 2, 2, 3, 4. Seems logical. Right. Oh, undeclared identifier. Yeah, it's add, idiot. Add. obviously, I should not be using this anymore. Get non-constant vector. I'm getting tired. It's 10 o'clock. Going to watch a movie. Continue with some tomorrow. I wish everyone a happy evening and a good night. Sleep well. At least it's a night here, so you know. Have a nice day otherwise. I'll be back tomorrow.